So now we're given a graph with a bunch of points. We want to graph y equals g of 0.5x. So the first thing we notice is that that 0.5 is inside the function. And what this is going to be is this is going to be a horizontal stretch by a factor of 2. That's how we would write it out in words. What we're going to do is we're going to multiply all the x coordinates by 2. So just like last time, where we had a bunch of points, in a graph like this, can you see that there's 4 key main points? And we label them here from left to right. It looks like we have negative 3, 2, negative 1, 5, 3, 3, and 4, negative 2. Those are the points on our original graph. And what we're going to do to each of these points is we're going to multiply our x coordinates by 2. So now what does that mean? We're going to get negative 6, 2, negative 2, 5, 6, 3, and 8, negative 2. Yes? Why is it by 2? Because the 0.5, if we wrote that as a fraction, the 0.5 that's out in front here is the same as 1/2. And whatever number is inside the function, we have to do the reciprocal. If it's a fraction, you can flip it, just 2 over 1. If you don't know how to change something to a fraction, maybe it's 0.4 and you can't think of how to change that to a fraction, then what you can do is you can take this number and say, what is 1 divided by 0.5? Go to your calculator if it's a calculator part, or figure that out without your calculator and you get 2. And every time you have a horizontal stretch or compression, whatever number is in here, what you need to do will always be the opposite, the reciprocal. Just like when we move left and right, things were the opposite. Here, too, it's going to be the opposite. So now that we have all those points, we can label them. Here's negative 6, 2. Here's negative 2, 5. We've got 6, 3, and 8, negative 2. Join them together. And so you see when something gets stretched, it gets stretched away from the y-axis. And the only point that didn't change was the y-intercept. Which makes sense because when you have a y-intercept, your x-coordinate is 0. And if you multiplied x by 2, 2 times 0 would stay the same. So there we have our new graph. Now it asked us to look at the domain and range of your original graph and the domain and range of your new graph. I'm going to use the set notation this time. So for domain being our x values, our smallest value is negative 3, less than or equal to x, and our largest value was 4, less than or equal to 4. Our range, our smallest value was negative 2, less than or equal to y, and our largest value was 5, so less than or equal to 5. If the transformation that we've done is a horizontal stretch by a factor of 2, and that affects our x coordinates by multiplying them by 2, does it make sense that your domain just gets multiplied by 2? Instead of going from negative 3 to 4, it now goes from negative 6 to 8. And since we multiplied our x values by 2, but we didn't do anything to our y values, does it make sense that our range didn't change? Okay, questions for this one? 4 and 8.